Welcome to the Robot Casserole FLL Camp. It's day 3, and today we're going to be looking more in depth into programming by teaching you some advanced tricks and techniques when it comes to the LEGO EV3 Mindstorm software. We'll take a more in-depth look at sensors, loops, weight, and switch blocks, my blocks, and we'll also show you some programs that you may find helpful when making your table runs. First, let's go more in depth on sensors. The sensors on a robot have a familiar function to our 5 senses as humans. Without our senses, we wouldn't be able to do anything on our own. The same goes with the robot. The sensors allow it to do certain things on its own without having us to manually input things into it. The sensor blocks can be found under the yellow tab in the EV3 software. Here's a list of all the sensor blocks you can use. Some of these blocks are barely ever used, but some of them are very useful to know. Of course, we already discussed yesterday about the basics of the touch sensor and the color sensor. These, of course, are the sensors that can detect different types of colors and can be pressed in order to change its state. Some of the other sensors include the ultrasonic sensor, which can judge how far something is away, similar to the way a bat does. There's the gyro sensor, which can keep track of what angle your robot is currently at, which can help you maneuver around the field better. Some of the sensor blocks that aren't tied to a specific sensor that you plug into the robot include the brick buttons. This sensor block just reads the buttons on the EV3 brick and sees if they have been pressed. There's also a motor rotation block, which reads how much the motor has been rotated. You probably won't be using any of the other sensor blocks all that much, but feel free to look them up, see what they do, and see if you can use them in any useful way. The sensor blocks do not move the robot on their own as previously stated, but rather they use the sensor to gather inputs for the robot to use. As we can see on the screen, the reading of the touch sensor, or the yellow brick, is being used to set the motor brake value on the medium motor block, the green block. If the touch sensor reads true, then the brake setting will also equal true, meaning that it will brake at the end of its rotation. These values are sent to each other using the data wires, as you can see marked on the screen. Here is a chart of all the different kinds of data wires. The first one is the logic wire, and it holds a true or false value. The best way to picture this is by picturing a light switch, which can be turned on or turned off. There are only 2 different states it can be in. This is the same with this, as it can either be true or false. The numeric wire holds a number value, so you can read a number from any of the sensors and use that to command another block. In this example, I have the robot read the buttons on the EV3 brick. Each of those buttons is assigned a single number value. I can then transfer that value over to a certain block, and I can tell how many times I want this loop of code to be done. In this case, 2. The text wire can transfer any amount of letters to another block. The numeric array and the logic array wires are basically the same as the normal logic and numeric wires, but instead of holding one value, they hold several different values. And that's usually what in programming an array means. It just means a certain list of values. These blocks are very useful. However, there is a much easier and more common way to use your robot's sensors, and that brings us on to our next topic. Here, let's take a look at loops, weights, and switches. Let's start with a loop. A loop is a block that repeats the code placed inside it forever or for however many times you specify. The way you can change however many times you go through it is by changing the condition, but more on that in a second. Next is a switch. The switch block is used to switch to a different task once a certain condition is completed. In programming, this is called an if-else statement. This is because you can often sum up this block of code in this statement. If this, then do this, or else do this. So let's say that our condition is that we want that when the touch sensor is pressed, we want the robot to move forward. But if it's not, we want it to move backwards. That's basically what it's saying, is that way it can switch between different tasks depending on if the touch sensor is pressed or not. Finally, we have the wait block. The wait block prevents the program moving on to the next block until a condition is completed. That can be anywhere from just putting to say wait for this amount of seconds to pass, or just going over a different sensor input. I'll show you a really cool example of how to use this block towards the end of the video. With the wait, loop, and switch blocks, you can change the condition by clicking the box marked above. Each of them will have a box similar to this. Here, you can see where you need to click in order to change the condition. And this is very similar for each block, and it's pretty easy to find which condition you want to do. So you may wonder, what are some useful things that I can do with these blocks? Well, here in the example, the loop block has a move block inside of the loop, and the condition on the left one, it is waiting for the touch sensor to be pushed. Now you can use this in order to detect a wall. If you back up and wait for the touch sensor to be pushed by the wall, then you can have it move on to the next task. On the right loop, the condition is set to the color sensor and is waiting for a black line to be detected. So you can use this as a way to, once the robot detects a black line, it can then move on to the next task. And the same principles apply to the switch block. When the block sees the line or hits the wall, you can tell it to do something. As you can see inside the red box, you can change a condition just like with the loop block. The difference is that it doesn't repeat the action inside the block infinitely. It just does it once. However, you can change this by putting a switch block inside of a loop block, and that allows you to go through that second action multiple times. Alright, so now let's move on to our next topic, and that's My Blocks. My Blocks are a way to condense several blocks or even entire programs into a single block. You can use these in several ways. By taking an action that is used very often, say if you wanted to turn 90 degrees a lot, you could just put that into one My Block, so you only have to write that piece of code once. There's also another really cool way that I'll show you how to use these towards the end of the video. To create a My Block, go to the upper left-hand corner of the screen and click the button Tools. Then you'll want to select the My Block Builder button, and then from there you can name your My Block as shown here on the screen and select an icon that you can use in order to identify your My Block. You can also add different parameters if you want to. Alright, before we head out, let's go ahead and talk about a few useful programs that you can implement into your table runs. So here's that cool example I was talking about with the My Blocks and the wait blocks. This program will save you a bunch of time at the table run. This program uses the wait block and with the touch sensor condition applied to it. If you put your table run programs into My Blocks, and then you can put them all into one single program. So basically, instead of having to look for your programs when you're swapping out your attachments, instead you can use a touch sensor and just press a button when the robot is ready to go. This will save you some time and allow you to do more missions. Like we discussed in day 1, it's important to save time when switching out attachments, and this is a way that you can account for that and just save a little bit more time. Finally is a line following program, and you'll see a lot of FLL teams do this. This program uses a color sensor to detect a black line and follow it. Here it is in action. When the sensor detects the black line, it turns one way, but when it sees the white board, it will turn the other way. And usually lines on an FLL field are structured to where there's a black line in the middle and 2 white lines on the outside. This causes the robot to quote-unquote follow the line and allows for easier lineup. This specific program uses a combination of both the switch block and the loop block to follow the line. I'm not going to show you everything in the program because it's going to be your homework later, which we'll talk about in a second. A line following program is very useful to align your robot accurately. That is if you don't have, say, a wall or anything else to help line you up. If you guys remember last year in the game City Shaper, the ramp had a line right in front of it, going right down the center. Now, you could just try and guess at the turn to go up the ramp, but a much easier way to do that is to have it detect the black line and then use a line following program to line your robot up. This line following program is really useful to know, especially in getting to places accurately. Alright, so that's going to conclude our discussion for today on advanced programming. I do have a couple pieces of homework that I want you guys to accomplish and bring tomorrow to the live session. The first one I want you guys to do is to write a line following program using what we've talked about today. Once again, try and use a loop, or try to use a switch inside of a loop in order to accomplish this. The second thing I want you guys to do is I want you guys to write a piece of code, and I want you guys to use one of the yellow sensor blocks in doing so. That way you can learn how to use those properly. Alright, this concludes today's video. Join us tomorrow and we'll talk a little bit less about the robot and a little bit more about your project and how to present your project, and of course all your other presentations. Alright, until next time, see you guys!